All right, last day of notes. Yay. We have made it to linear regression t-testing. We did the foundation of this yesterday with linear regression t-intervals. So a lot of those condition ideas remain the same. We're just going to switch from estimating that true proportion beta of the population slope of the least squares regression line to testing. All right. So also just enjoy your joke of the day, right? Your linear regression joke of the day. Not funny, kind of funny. You saw this earlier. Juan, where? Yeah, it's on your assignment account. I just didn't know if anyone looked at this. All right, anyways. So what we're going to do today is, I kind of like to boil it down. So what we're going to do in this section, compared to what we did yesterday, is we're going to assess whether or not we have statistical convincing evidence of, maybe again with a null, that our beta is equal to 0. So let's let our null hypothesis, because we're going to do an inference procedure here. We're going to state that our null is going to be that beta is equal to 0. Again, recall that beta is the true slope of the population least squares regression line. What that means, if beta is equal to 0, is that there is no relationship between the two variables. All right, that there is no relationship. They are not related at all. Basically, a slope of 0 is a flat horizontal line. Sounds like nothing. Right? There's nothing. So they are not related. Versus the alternative of one of these three. Okay, so we're going to say, all right, maybe we have evidence to show that the slope, the true slope of beta there, is greater than 0. And if it's greater than 0, that means there's a positive relationship between two variables. That makes sense, because as one thing goes up, as x increases, so does y. Or maybe there's a negative relationship we can inquire, maybe if beta is less than 0. So there's some sort of negative relationship. Or it's just not 0, which means we're just going to say, hey, there is a relationship between these two things. All right? So that's what we're going to do in terms of testing hypotheses for a linear regression t-test. Is there a relationship versus no relationship? Maybe the relationship is positive. Maybe it's negative. You're going to be given that, okay, in the stem of the problem within the scenario. You're going to try to see if you have enough evidence to prove there is a positive relationship, negative relationship, or a relationship versus no relationship. All right? Do you kind of see how the null and the alternatives are going to work for this test? Okay. So I want you to boil it down. We're just trying to assess if we have a data set, if a relationship exists. So that's going to be our alternative. Versus the claim, or the null there, is that there is none. You guys good with that? Okay. Autumn, if you want to take a picture real fast, I'm going to have to move it. Okay. All right, so this is already printed for you on the paper there. It says, suppose that the conditions for inference are met. Then we're going to test HO. It's going to be beta is equal to, generally it's 0. I guess it could be other things, but generally it's not in terms of the AP curriculum. It's generally going to be 0. So your test statistic is going to be simply, well, if this thing goes to 0, that means our test statistic should really be the sample slope B over SE sub B. Does anybody remember what SE sub B was from yesterday? What do we have? What's it called? Standard error of the slope. So it's the standard error of the slope. Let's go ahead and write that again. Some of us seemed a little hesitant. So this is the standard error of B, or B, excuse me. Standard error of slope. Remember that standard error of slope? It's going to be the average distance / error between B and beta. That's generally what that is, all right? For homework tonight, you're going to have to interpret that in context. So you're going to kind of interpret it like a standard deviation. It's the average amount your sample slope is going to be off when predicting your population slope. Kind of like every other standard deviation. How much we're off from the mean, or how much for the residuals. How much we're off in our predictions of using the least squares regression line from the actual values. right? So that's the idea here with this. Again, you're going to use degrees of freedom n minus 2, and that's pretty much it. So we're just switching to a test statistic. So if you don't have the test statistic given to you, you just take b and divide it by SE sub b. Pretty easy, right? You just need to know what b and SE sub b are, and you got the t statistic, and then you just put that in the calculator because you use TCDF. Cool? The beta, that's usually going to be 0 because your null is going to be generally beta equals 0. So that's why I say it's approaching 0. Because if that's always 0, b minus 0 is just b. So you don't need the beta. But if it b or beta is something other than 0 in your hypotheses, that's when you would need to like subtract it from b. But what I'm saying, and generally in the AP curriculum, it's not. It's not going to be anything other than 0. All right, here are the conditions. This is generally stated for you down there. You're going to follow liner. You guys remember liner from yesterday? L is linear. I is independent. N is normality. E is, that was the tricky one,
Equal variance.
Equal variance. The same number of residuals above and below the x-axis. R is random. Okay. So that's on your t-interval notes. I would look over that. You guys need to know that. Oftentimes, they're going to be given that it's checked and conditions have been checked and verified, so that's nice. If not, use a residual plot. Hopefully, you have a residual plot given to you. Generally, if they don't give you that the conditions are met, they're going to give you something else to use. So you're going to make sure the residual plot shows no pattern, same number of data points above and below for equal variance. Make sure your plot's linear. If you're going to use a linear regression t-test, your data should be, I don't know, linear. That makes a lot of sense. And random. It has to come from a random sample, random assignment sample. Minitab. You've got to use Minitab to find SE sub b, t, and the p-value. All right, so you're going to be doing that. You guys good? All right, let's look at a problem. So here we have a taxi cab company in a large city that charges passengers a flat fee to enter a cab plus an additional fee per mile. It's almost like Uber, right? Like Uber charges you for how far you go, but they kind of calculate that cost up front, right? Back in the day, you had to pay some certain fee plus for how far you traveled. Has anybody ever been like in a regular taxi versus like an Uber? Okay, cool. You guys know how that works? Okay, so when you enter the car, you're going to have to pay money. And then for how far you go, you pay based off that distance. That make sense? Okay, company wants to develop a new method for determining fares based off mileage and a flat fee only, not time spent stopped in traffic. Because you ever take a cab and then it, like all of a sudden starts increasing your fare even though you haven't moved? Because they also charge you based off the time you spend in the car as well. Kind of sucks. A random sample of 10 recent cab fares was selected and the distance in miles and the fare in dollars were recorded. A regression model was to fit the data, and the output, scatter plot, and residual plot are given below. All right, so here's your output in the middle. You have your scatter plot over here on the left. You have your residual plot kind of in the middle there. What is going to be our explanatory variable? What's our x variable here? Distance. So that's going to be what we're going to use to predict what? We're predicting the fare. So we should have a predicted cost here, right? Okay, so this is what we're predicting. Remember, the y variable is generally what you're going to be predicting there. For part A, can you state the equation of the least squares regression line for these data? Can you come up with the least squares regression line using the chart? Answer should be what? Yes. Should be, first thing you're going to write is a hat. What am I going to write for the hat? Fare. So fare hat equals least squares regression line. Start with the y-intercept. Where do you find the y-intercept? Where it says intercept, and then where that intersects with, I don't know, estimate. Okay, so that's going to be 4.296 plus what? 1.229 times what? Distance, which is going to be in what? Number of miles. So we're going to be talking about number of miles. All right, can you get that? Nice. You did part A. Congratulations, folks. Good? Next. Finding a residual. So same problem, part B, says suppose that a 2-mile trip costs $7. Find the residual for this point and interpret the residual in context. All right, so what are they giving you here? They're giving you the point what? 27. What do we know about $7? This is going to be our observed value, correct? How do you find a residual? Because that's the big thing here. How do you find a residual? Distance from the line, but how do we calculate it? That's going to be observed minus the estimated or observed minus predicted, right? So we know our observed is 7. You guys agree with that? Minus, how are we going to find the predicted value? You're going to plug in 2 for your distance. So on the previous screen, right, we had fair hat is equal to 4.296 plus 1.229 times the number of miles. How many miles have we traveled? 2. So we can plug in 2 to find the predicted figure. So 4.296 plus 1.229 times 2. 6.75. So that's going to come up here, and I'm going to subtract that. So we know about our residual already. 7 minus 6.754. It's going to be a positive value. It's going to be a positive 0.246. So what does that mean if we have to interpret it? We're talking about a residual. It's going to be the error from the observed minus the predicted. We have this error. So this is an error. Did our least squares regression line over-predict or under-predict? Okay, so this right here, we were going to say our least squares regression line under-predicted. I'm going to write that in the color. Under-predicted. The cost of a 2-mile trip by what? Put in context. 25 cents. Because remember, we're talking about fare. We're talking about money. So dollar signs, yo. You guys good there? Cool. I would highly recommend that you make sure before you take the AP exam next week, you know how to calculate the residual and be able to interpret it. I have a feeling you're going to see that at some point. Multiple choice, free response somewhere. Okay, so super important. Okay, which is why we're reviewing it. Yep.
Is there a quiz on the 3 interval?
Test, or no, the quiz the weekend is just 3. So it's going to be not the regression stuff. Or not. It is the regression stuff, not the inference stuff. So not a T interval, not a T test, just like interpreting S, R squared, correlation, knowing how to use that, describing 10. There's a free response that you'll turn in on Monday on paper. You right? Some of you guys might type it in. I don't care. Do whatever. All right, now let's do a test with this. Now the test is going to be super relaxed, but we're going to go through each of the components, okay? I'm going to go ahead and tell you that you're going to be using this box primarily for it, all right? I'm going to show you how you get all of this stuff, all right? But if we're asked to provide, is there statistically significant evidence that there is a relationship between distance a passenger travels in the cab and the fare of the cab ride, that means you're going to do an inference procedure. You need to kind of compare it to some sort of alpha level, right? What alpha level do you guys want to choose here? So we're going to compare it to 0.05. All right, so let's do a phantoms here. Notice this last statement that should make us all happy. Are you happy there? All right, congratulations, AP Stat students. You have reached the 14th and final inference procedure that you need to know. A linear regression t-test, which is what we're about to do. Okay. D. State R parameter. So what do we want to do? We don't want to estimate because this is a hypothesis test. We want to do what? We want to test. I wrote estimate because I had estimate on my mind. We want to test the following hypotheses. At alpha equals 0.05 significance level, where beta is equal to, you need to define your parameter. So you got to say what beta is. Remember, beta is a parameter. It represents a population. It's the population slope of the least squares regression line relating distance a passenger travels and cab fare. So we want to test the hypothesis. Well, we haven't written it, but we will. Yeah, you will. Trust me, this is not going to be very long. Because a lot of the calculation part, this is the longest piece. The calculation part is going to go like this, because you're going to look at the table. This is the setup. All right, what should HO be? We want to determine if there is a relationship. So beta should be equal to 0, which signifies what? There is no relationship. We want to just assume there is a relationship, right? So what should HA be if we want to say there is a relationship not equal to 0? So we're going to do not equal to 0 there. Assumptions? All checked and verified be a problem. But let's say they weren't. What would we look at? What are you looking at for checking? Linear. Is it pretty linear? Is the residual plot pretty scattered? Do we come from a random sample? Good. Pretty good. Good enough. Conditions met. You guys see what I'm saying that you could use? Is it linear? So you would make a statement. The scatter plot shows a strong, positive, linear relationship. The residual plot has no apparent patterns, and we came from a random sample. Inference for this scenario should be okay to conduct. That makes sense? Like you would just kind of comment on the major pieces, right? Next. Oh, I deleted that. Okay, so I need to I actually made myself a second slide because I knew I would need to, but I guess I'll just do this. Oopsie. Hold on. All right, what's next up in our hypothesis testing? N, which is going to be naming it.
Linear regression t-test.
Linear regression t-test. Bless you. Bless you twice. All right, T. It's going to be our test statistic. Since it's a t-test, we're going to do t equals. All right, do you guys remember how I told you you're going to come up with that? Click above. I mean, it's on the page. It's going to be B over what? SE sub B, right? So that's technically this. So I want you to watch. Do you guys know where B is? Yeah, what's that value? 1.229 over, what's SE sub B? 0.166. I have a question. Can you give me let me try that again. Just do me a favor. I actually don't have a question. I lied. Sorry, I'm a lie. Can you divide those two numbers real fast for me? 1.229 divided by 0.166.
Why is it different?
Because it's an estimate, right? But doesn't that look familiar? Isn't it basically that? Okay, so this number here is B over SE sub B. Yeah, it does. So that's your key statistic. Yep, it has. So there you go. There's your key statistic. Guess what's next to it? The p-value, which is what? Less than 0.0001. Now, I do need you to make this note. Please make this note. This p-value is for two-sided tests only. So my question is, if you want to determine if there is a negative relationship or a positive, which is one-sided, what would you have to do to this p-value? Divide it by 2, because this represents a two-sided. So this is double the probability. So if you wanted to do a one-sided, you would have to divide it by 2. Does that make sense? So let's make a note here. Divide by 2 if one-sided test. Divide by 2 if it's a one-sided test. All right, O. Probability that T is not equal to not equal to 7.418. That's going to be equal to less than 0.0001. Let's make our decision. So 0.0001 less than that is going to be less than 0.05. So that means we're going to do what? Reject HO. You see how I told you the test is going to speed up really fast? But literally, what do? You look at the bottom row and it's basically there. No, he didn't really say that. That was a ghost. What is that? Second period's almost alive and with me today, making jokes. Wow.
I like this stuff.
You like the quiet? Save it, rest over for it. All right, let's make our statement. What's our conclusion statement here? Since our p-value, you should know how to do this. It is less than alpha. That's the linkage. So when I had you guys write the statement, I'm asking you to link the p-value to these statements. So that's going to be a component on the AP exam. We reject HO, right? What does this mean we have?
To suggest.
To suggest, not to prove. We can suggest, to claim, to support, but not to prove. There is statistically significant evidence that there is a relationship between number of miles traveled. I forgot that. The number of miles a passenger travels, I guess I should say. And fare. Sure, done. Okay. All right, guys, good with that?
Yeah.
Cool. There is a back, but we're going to wait to do that. What I want to show you on Monday is I want to show you if you have like a data set like this, how can you use your calculator to still do both the linear regression t-test and the linear regression t-interval. So we will do this on Monday to finish up and kind of just remediate and review what we did Thursday and Friday this week. Does that make sense? It's not hard. I just want to show you how to do it because I think it's important. All right? So we will do that together. It's not going to be anything you need to know, but today is like the new stuff. Like Monday is kind of new, but not really. So I'm going to call this the last day of notes. Woo! That's it? That's all I get? I taught you all this stuff this year, and you go, blue?
Yeah, well, that's it.
It's good ride.
Because we're still gonna be other things. When you say basically,
This is the last day school, I feel like it never ends.
Anyways.
Any,
Anything for YouTube? Nothing?
mascot.
No, you guys have nothing to say?
Don't take AP Chem.
Don't take AP Chem? That's rude. Do you want to say goodbye or anything?
I mean, we still got a whole 3 weeks. And we're gonna be in here every day doing
It's
stuff.
not over yet.
I'm not getting ahead of myself, because then I get excited and then I just get mad. Then I don't care.
It's like project's the only thing.
Yes. Bye.